All right, hello, my wonderful students. This is part 3 of Foldable number 2 for 7.4 properties of logarithmic functions. And this one is using a logarithmic scale. So for this one, we have the pH of a substance equals the negative log of H plus at the end, depending on the subvariable, where H plus is the concentrated of hydrogen ions. So H plus of A is for our household ammonia, which is 10 to the negative 11. And our H plus V is for our vinegar, which is our 6.3 times 10 to the negative 3. And then what is the difference of pH levels of ammonia and vinegar? So we're going to kind of have to set this up first and then kind of, go from there. Well, first things first, we're going to go ahead and just write our equation. We're doing it in red just so it kind of stands out. So our pH is going to be set in the form of negative log of our H plus, negative log of our H plus. And this is how each one is. So one's going to have an A here for ammonia, and one's going to have our V here for our vinegar. And we kind of have to like set up an equation. So let's set up an equation, right? So it's asking for what is the difference of the pH levels of ammonia and vinegar. So we're going to go ahead and write ammonia first. So our equation is going to be, remember these all have to be in this format here. So we have our negative log of our H plus, and our first one is ammonia, minus our negative log of our H plus, which is our vinegar, parentheses, but negative times a negative is a positive, so we can actually rewrite this as negative log of H plus A plus our log of H plus vinegar. But we don't really know what to do with this, right? Because this doesn't really compute with our powers or our quotient rule or anything, because we haven't really done anything. Lucky for us, this is addition. So we can actually switch these. So this one would be in the front because this is positive, and this one would be in the back since it's negative. So we're just kind of switching the position, which we can do because it's just basically adding. And this is now going to look like this. I'm going to write it here, and then we'll do more work over here. This is going to look as a log. And we're going to write this one first of our H positive of vinegar minus our log of our H positive of ammonia. So that's what we have here. And now we can clearly see this is going to be our quotient rule. So we're going to be able to expand and do things after. If we're going to be going in anyways. But it looks like from this one we're going to be mostly expanding, so we might actually not have to use our quotient rule. Alright, so we're going to rewrite this equation over here just so we have it. We have our log of H positive for vinegar, and we're going to subtract our log of H positive for our ammonia. Remember, our H positive is just our concentration of hydrogen ions, which is a scientific wonder piece. All right, so now we're just going to substitute. So we see we have the log of H positive vinegar, but we know that vinegar is going to be our 6.3 times our 10 to the negative third power. So this is actually going to be our log of, I think we'll just write this in parentheses, 6.3 times our 10 to the negative 3 minus our log of H, or the hydrogen ion of ammonia, which is 10 to the negative 11. So we're going to go ahead and write 10 to the negative 11. This is, once again, this was substitution. Now we can go ahead and distribute here, because this is our product property, right? We have this times this, so we're gonna kind of like separate it using our product property, and we're gonna do this one in green. So this is gonna be the log of 6.3 plus the log of 10 to the negative 3, and it's still gonna be minus log 10 to the negative 11. Oof, that is fun. Alright, the cool thing for us, because these logs are not given a base, we know they're secretly log base 10 and log base 10 and log base 10. That means this log base 10 of 10 to the negative 3 power is just going to equal negative 3, and log base 10 of 10 to the negative 11 is just going to be equal to negative 11. Or, negative 11. So, I mean, I can do a little side note here to show you what I mean. So if I have the log, this once again is the side note. If I have the log of 10 to the 10 minus 3, this is equal to negative 3 times the log of 10 to the 10. And if you have the log base 10 of the same number 10, or any number that are the same, then it's equaling negative 3 times 1, which is equal to whatever number's in front, which is negative 3. So this one's going to be negative 3, and this one's going to be negative 11. So when I rewrite this, this is going to be log base 10 of 6.3 minus 3, and then we're going to have minus our negative 11, which is going to give us a positive 11 there. So we're going to have our log of 6.3. This is minus 3 plus 11, which is going to give us a plus 8. And this is what we now put into our calculator. So we're going to go into our wonderful calculator, and we're going to put in log base 10 of 6.3, and we're going to go ahead and go to the side, and we're going to add our wonderful 8, and we're going to get a, I guess we could use approximately 8.8. But once again, this is a word problem, so we're going to go ahead and write this. So it's going to be the pH level of, and I think we were doing of ammonia first. Ammonia is about, because we rounded, 8.8 times greater than, not times, it's just 8.8 greater. Sorry, I was thinking of the earthquake problem. The pH level of vinegar. And it's going to wrap it up for this problem here.